Today's lesson is rational exponents. What we will be doing is rewriting expressions using those exponents and using radicals. So square root of a, I referenced this yesterday's lesson, that the square root of a is actually an exponential function because what a is, a square root is the exact opposite of a square, right? A square is something to the second power, well, square root is something to the 1/2 power. So this is a equals, square root of a equals a to the 1/2 power. Well, what if we have a different root? What if it's not a square root, but like a third or a fourth root? Well, so what do you say this is the nth root, right? That number would go right here. And what that means is that we would need n, what multiplies itself n times to equal a. And so this is a to the 1 over n. Now finally, we'll get something in the numerator here when we have a power near the a. So this is the nth root of a to the m power, gives us a to the m over n. Now this can also be written as the nth root of a to the m power, right? I have seen them both ways. Today's lesson's probably going to focus on this method. And they both would equal a to the m over n. So starting off, we're just going to rewrite the expression using rational exponents, meaning rewrite using fraction exponents. So the fifth root of 2 is, I have 2 to the, I don't see a number, so it's 1 over 5. So 2 to the 1/5. This is the third root of x to the 5th, so we're going to have x to the 5 over 3. X to the 5 over 3. Now we have the fifth root of 3x squared, and we're going to rewrite the expression using rational exponents again. Now, I do not see that the 3 has a squared, so I cannot say 3x to the 2/5. Why not? This would need a square too, right? It would look like that for me to write that. So what I need to do is need to say this is parentheses 3x squared, close parentheses, to the 1/5. And if you want to, you can distribute this in. We did this math earlier in the semester that this can multiply into both pieces. So 3 to the 1/5 and 2 times 1/5 is 2/5. So we could also write this as 3 to the 1/5 x to the 2/5. I am only looking for this top one as an answer. We may use the bottom one later on if we're simplifying values that can be simplified. Moving on, we've got the fourth root of 5xy. This is 5xy to the 1/4, right? None of these have a power, so we don't really need to worry about it. You could also say 5 to the 1/4, x to the 1/4, y to the 1/4. A little more of a mouthful when you're saying that way. Next, 2 to the 1/4 is what, right? Rewrite the expression using radicals. So now we're going the other way. What does this mean in square roots? This means 2 to the 1 and take the fourth root. So fourth root of 2 to the 1. 2 to the 1 is just 2, so we could also write this as the fourth root of 2, right? Because this really isn't doing anything. Now, if it is a larger number, like say it's 3 to the 3/5, you do not need to multiply it out. You can leave it in exponential form, but in this case, 2 to the 1 is 2, right? Generally, you don't see a 1 there, or a square root 2 here. For example, x to the 1/2 is the second root of x to the 1. Well, we don't see a 2 here. You usually only write the number if it's 3 or more, and you usually won't see a 1 right here, right? We don't call this 1 x to the 1, right? We just write it as square root of x. So that would be how to write it in a simpler way. One more set of those. Try these on your own if you're feeling confident. X to the 5/6 equals x to the 5, and then take the 6th root. 3n to the 3/2 gives us 3n to the 3rd power, and then square root of that, or square root of 3n cubed. You can distribute it technically square root of 3 cubed n cubed, but I just left it where it's at. Next, simplify. We've got 64n to the 4th, all to the 1/2 power. Technically, this means the square root of these values. However, we can use the distributing rule I talked about earlier, where the half goes to both pieces. Why would we use this? Well, 4 times half is 2. So that's going to keep me from having to do square root of this variable, right? 4 times half is 2. So I'm going to write this as 64 to the half times n squared. And now I just need to figure out how can I rewrite this. 64 to the half is the same as square root of 64. Well, square root of 64 is 8, so we can just write this as 8 and then the n squared. One more of these. We've got 5 to the 6, x to the 12, to the 2/3. So what is 2/3 of 6? Right? Going to distribute to both. So 6 times 2/3. 6 times 2 is 12. Divided by 3 is 4. And that's what we get here. You could have also, 6 and 3 both have a 3, so we cancel to get 2. 2 times 2 is 4. Right? Just like we were dealing with these in chapter 11, you can do it that way. However, we usually have like x plus 3 and x plus 3, things like that. We're more chapter 11, 3, 4 lessons. But anyways, this is a way just to make sure you keep it straight and simple. You multiply the top pieces and multiply the bottom pieces and then divide when you're done or simplify. Same thing with 12. 12 times 2/3. Well, 12 times 2 is 24. 1 times 3 is 3. 24 divided by 3 is 8. So x is going to have the 8 exponent. 5 is going to have the 4. And we're done. And that wraps up today's lesson and this year's lesson. Let me know if you have any questions.